Statistics, Modeling, and Finance, Chapter 3, Measures of Dispersion, page 20, Probability. Probability. First, let's talk a little about the idea of probabilities. Then we'll tie in how we can use the standard deviation. We mentioned earlier that there are 38 numbers on a roulette wheel. The zeros are also numbers. And therefore, with each spin, there is a 1 out of 38 probability that any one number might appear. But it's not foolproof. Every number does not come up exactly every 38 spins of the wheel. There are 6 sides on a die. So if we roll one die, each number has a 1/6 probability of coming up. If we have a pair of dice, there are 12 total sides. Each time we roll a pair of dice, 2 numbers come up on top. Early variations of dice have shown up in Egyptian paintings, traced back to over 3000 BC. However, with each roll of 2 dice, there are 36 possible combinations. We could get 1 and 1, 1 and 2, 2 and 1, etc. What matters is the total of the 2 dice. The total has various probabilities. There is only one way to get a 2. 1 and a 1. There is only one way to get a 12 and 6. And 6. 12 to 6 and 6. So the probability of rolling 2 1s is only 1 in 36. The same goes for the chances of getting 2 6s. It is more likely that you would get a 3. You could get a 1 on the first die and a 2 on the second die, or you could get a 2 on the first die and a 1 on the second die. Therefore, your total probability of throwing a 3 would be 2 out of 36. What do you suppose is the most probable number? A 7 can be accumulated by throwing a 1 and a 6, 2 and a 5, 3 and a 4, as well as a 6 and a 1, 5 and a 2, and a 4 and a 3. Here is a table showing all the possible combinations. Shows the numbers, shows the dice combinations, shows the total combinations. End of page.